Fuse Part 1. Fuse. A fuse is an electric/electronic or mechanical device which is used to protect circuits from overcurrent, overload, and make sure the protection of the circuit. A fuse contains a current-carrying element sized so that the heat generated by the flow of normal current through it does not cause it to melt the element. However, when an overcurrent or short-circuit current flows through the fusible link will melt and open the circuit. Fuses are sacrificial devices used to protect much more expensive electrical components from the damaging effects of overcurrent. Fuse. Construction of fuse. A fuse consists of a metal strip or wire fuse element, of small cross-section compared to the circuit conductors, mounted between a pair of electrical terminals, and, usually, enclosed by a non-combustible housing. The fuse is arranged in series to carry all the current passing through the protected circuit. The resistance of the element generates heat due to the current flow. The size and construction of the element is observation or experience determined so that the heat produced for a normal current does not cause the element to attain a high temperature. If too high a current flows, the element rises to a higher temperature and either directly melts, or else melts a solder joint within the fuse, opening the circuit. The fuse ideally would carry its rated current indefinitely, and melt quickly on a small excess. The element must not be damaged by minor harmless surges of current, and must not oxidize or change its behavior after possibly years of service. The fuse elements may be shaped to increase heating effect. The fuse element is made of 1. Zinc, 2. Copper, 3. Silver, 4. Aluminum, 5. Alloys to provide stable. In large fuses, current may be divided between multiple strips of metal. A dual-element fuse may contain a metal strip that melts instantly on a short circuit, and also contain a low-melting solder joint that responds to long-term overload of low values compared to a short circuit. Fuse elements may be supported by steel or nichrome wires, so that no strain is placed on the element, but a spring may be included to increase the speed of parting of the element fragments. The fuse element may be surrounded by air, or by materials intended to speed the quenching of the arc. Silica sand or non-conducting liquids may be used. Temperature. A fuse rated for 1A at 25 degrees Celsius may conduct up to 10% or 20% more current at -40 degrees Celsius and may open at 80% of its rated value at 100 degrees Celsius. Operating values will vary with each fuse family. In Industrial Material Datasheet. Selecting of fuse. Fuse rating equals power/voltage, x 1.25. For example, you have to find a right size of fuse for 10A 2-pin socket, 1000W/230V, x 1.25 equals 5.4A. In the above example, 1 kW is the power rating which can be controlled through the 2-pin socket and the main supply voltage is single-phase 230V AC, but you should go for the max, i.e. 6A fuse rating instead of 5.4A for safe and reliable operation of the circuit. Fuse rating. Verification or particular type. I current rating of the fuse. 2 voltage rating of the fuse. 3 time current characteristic, i.e. fuse speed. 4 approvals by national and international standards agencies. V manufacturer/part number/series. 6 interrupting rating breaking capacity. Special features. Glass cartridge and plug fuses allow direct inspection of the fusible element. Other fuses have other indication methods including indicating pin or striker pin, extends out of the fuse cap when the element is blown. Indicating disc, a colored disc flush mounted in the end cap of the fuse falls out when the element is blown. Element window, a small window built into the fuse body to provide visual indication of a blown element. External trip indicator, similar function to striker pin, but can be externally attached using clips to a compatible fuse. Indicating pin or striker pin, element window, indicating discs. Some fuses allow a special purpose micro switch or relay unit to be fixed to the fuse body. When the fuse element blows, the indicating pin extends to activate the micro switch or relay, which, in turn, triggers an event. Some fuses for medium voltage applications use 2 or 3 separate barrels and 2 or 3 fuse elements in parallel. Automotive fuses, blade fuses, glass tube, fuse limiters, Bosch type, automotive fuse. Automotive fuses are a class of fuses used to protect the wiring and electrical equipment for vehicles. They are generally rated for circuits no higher than 32 volts direct current, but some types are rated for 42-volt electrical systems. They are occasionally used in non-automotive electrical products. Glass tube, automotive fuses, blade fuses, fuse limiters, Bosch type. Types of electrical fuse: low voltage fuses, high voltage fuses. Low voltage fuses. Fuse is a current interrupting device which breaks or opens the circuit by fusing the element when the current in the circuit exceeds a certain value. Fuses are mainly categorized into two types, i.e., high voltage fuses and low voltage fuses. Low voltage fuses can further divide into two types, namely semi-enclosed or rewirable type and entirely enclosed cartridge type. Low voltage fuses, rewirable fuse, totally enclosed or cartridges type fuse. Rewirable fuse. The most commonly used fuse in house wiring and small current circuit is the semi-enclosed or rewirable fuse. Totally enclosed or cartridges type fuse. The fuse element is enclosed in a totally enclosed container and is provided with metal contacts on both sides. There have two types: fuse, D-type, link type, I-knife blade, 2 bolted type. Rewirable fuse, totally enclosed or cartridges type fuse. D-type cartridges fuses. It is a non-interchangeable fuse comprising S fuse base, adapter ring, cartridge, and a fuse cap. Link-type cartridge or high rupturing capacity, HRC. High rupturing capacity cartridge fuse, commonly called HRC cartridge fuses, have been designed and developed after intensive research by manufacturers and supply engineers in his direction. Knife blade type HRC fuse. It can be replaced on a live circuit at no load with the help of a special insulated fuse puller. Bolted type HRC link fuse. These are bolted on the plates of the fuse base. High voltage fuses. High voltage fuses are used to protect instrument transformers used for electricity metering, or for small power transformers where the expense of a circuit breaker is not warranted. Pole-mounted distribution transformers are nearly always protected by a fusible cutout, which can have the fuse element replaced using live line maintenance tools. Medium voltage fuses are also used to protect motors, capacitor banks, and transformers and may be mounted in metal enclosed switchgear, or rarely in new designs on open switchboards. High voltage fuses. Characteristics of a fuse: current rating and current carrying capacity of fuse, voltage rating of fuse, breaking capacity of a fuse, response characteristic, rated voltage of fuse, packaging size, fuse application. introduced by. Electric fuse was invented by Thomas Alva Edison in 1890. Blade fuses, the many fuses were developed in the 1990s. 1. What is automotive and their types? 2. Types of fuse and their description. Will be in next video. Your turn to interview me. What questions would you like to ask me?